Hello and welcome to Mr. Davis' classroom. This is Algebra 1, Lesson 7.7. Today we're talking about exponential growth and decay. Our objective today is to model exponential growth and decay. Here's a warm-up for you guys to try. Once you're done with the warm-up, please move forward. Okay, so exponential growth is an exponential graph, but it's talking about the growth of some type of population. That could be human population, animal population, money population, germ population, basically anything that you can count. So it has the exact same formula as before. The only difference is there's some restrictions. One, A has to be positive, B has to be bigger than 1. The base, or B, is called the growth factor, which is 1 plus the rate of change. And so, and A is the initial amount. So that's where we start off at, is our A value. So knowing that, let's go ahead and try this one. It says, since 2005, the amount of money spent in restaurants in the United States has increased by about 7% each year. In 2005, about $360 billion was spent at restaurants. If the trend continues, how much will be spent at restaurants in 2015? Okay, a few things. Since they said since 2005, 2005 is my baseline. All right, 2005 is my initial population. And 2005, it says, was about $360 billion. So that's my A value is 360, okay? Now, I'm going to leave it as 360 because I don't want to write a bunch of zeros afterwards. We'll just know our answers are in billions, okay? My B value, well, that's my growth rate. And so we see right here it's 7%, but we're just not going to write 7%. What we need to do is remember it's 1 plus the growth rate, which is 1.07 is my B value, okay? So we get y is equal to 360 times 1.07 x. Well, that's the equation. Now they want to know how much was spent at restaurants in 2015. Well, we're not going to put in 2015 in for x, because since we said 2005 was my starting point, that's what we wrote as 0. All right, so 2005 was my 0. That means 2006 is 1, 2007 is 2, 2008 is 3, 2015 would be 10. So we're going to plug in 10. Y is equal to 360 times 1.07 times 10, because that's years since 2005. So we get 360 times 1.07 to the 10th power. So this tells us there's going to be about $708 billion spent in restaurants in 2015. All right, here's one for you to try. Same type of problem, only talking about population growth. All right, be sure to get your A and B values correct before solving. All right, now another type of population that we could talk about is money. And in banks, we have interest paid. And so we're going to learn how to do compound interest. And that's a type of exponential growth. The formula is right here. A is equal to P parentheses 1 plus R over N parentheses N to the T power. It gives a definition of everything that's in here. Right? P is the principal, R is the rate, N is the number of times compounded per year, and T is the time in years. Well, but what we really have is the same type of formula as we just were talking about. So we had A times B to the X power. Well, A was my initial population. My initial population in here is P, or my initial deposit. B was my growth rate. And we found B by taking the growth rate plus 1, right? So we have 1 plus my growth rate. And then X was the amount of time that we're measuring, and that's the amount of time we're measuring. So really, it's the same exact equation. The only difference is we're given specific variables with compound interest. So let's try one. Suppose that when your friend was born, your friend's parents deposited $2,000 into an account paying 4.5% interest compounded quarterly. What will the account balance be after 18 years? Well, let's figure out, first let's write down the compound interest equation, which is going to be principal, parentheses 1 plus rate divided by compounds per year times time times the compounds, right? And I use the same variables on all of those. Oh, I guess I need to use n instead of c. My mistake. So these should be n's. Okay? And that's all going to be equal to the amount in the account. Well, let's see. What about p? Do we know p, the principal amount? It is 2,000. What about my rate? What's my rate expressed as a decimal? Well, it's 4.5%. That's 0.045. N is the number of compounds per year. Well, quarterly, well, there's 4 quarters in a dollar, so there's 4 quarters of a year. And T is time, which is 18 years. So let's plug all this in. So amount is equal to 2,000 times 1 plus my rate over number of compounds per year times my time times compounds per year. All right, well, let's do this piece by piece. All right, so I'm going to do 1 plus 0.045 over 4. So I get 2,000. If I do this inside part here, I get 1.01125. And 18 times 4 is 72. Now I think I can plug all that in the calculator without making a mistake. 2,000 times 1.01125 to the 72nd power is 4,475.53. So the $2,000 has grown to be about almost $4,500, just under $4,500 for his 18th birthday. All right, here's a compound interest problem for you. When it's compounded monthly, there's 12 compounds per year. Okay, exponential decay is kind of opposite of growth, right? Growth is when a population is thriving, is growing. Exponential decay is when it's dying or getting smaller. Similar equation, right? Similar meanings, right? We still have initial amount. Still have the exponent. The only difference is the base now is going to be between 0 and 1, right? Between 0 and 1 means decay. If it's larger than 1, it means growth. So it's going to be decay if it's between 0 and 1. Similar to the last one, though, a lot of times, like on exponential growth, we did 1. So on growth, we did 1 plus our rate. On decay, we'll have to do 1 minus the rate, okay? Which makes sense. So let's try this one. It's talking about a kilopascal is a unit measure of atmospheric pressure. The pressure at sea level is about 101. For every 100 or 1,000 meters increase in altitude, the pressure decreases by about 11.5%. What is the approximate pressure at an altitude? Well, y is equal to a times b to the x. Well, a is my initial population. Here we're talking about kilopascals, which my initial one is 101, right? That's at sea level. That's at 0. My b is going to be 1 minus the rate, which is written in decimal still. 1 minus 1.15, which I think is 0.885. And then we get to plug those in. So we get y is equal to 101 times 0.885. You know what I'm going to do? I'm going to put parentheses around that because it looked kind of confusing. All right, and then it says, what is the approximate pressure at an altitude of 3,000 meters? Now, again, we do not want to plug it 3,000 into my exponents because it says for every 1,000 meters. So how many 1,000 meters did we increase? 3. So we're going to plug in 3. Y is equal to 101.885 is equal to 3. Well, we can do that in a calculator. Simple enough by punching in 101.885 to the third power. And we see that we get just about 70. It's 70.0086, but that's so small, I'm just going to say it's about 70. All right. Here's got it for you. Make sure that you refer to the previous problem and your notes. Here's your homework assignment, page 459. I hope you enjoyed this, and thank you for coming to Mr. Davis's classroom.